Good afternoon, everyone. Today we are going to study Block 2 Demand and Revenue Analysis, part of it, that is Unit 5 Demand Elasticity. Now, in the last class, we studied about the demand, law of demand, market demand, etc. Now we are going to study about the responsiveness of change in one particular variable, say dependent variable, due to change in the independent variable. That is the basic idea behind demand in elasticity. Now the objectives are to understand the concept of elasticity, to define various kinds of elasticities, and to apply the various measures of elasticity to real world situations. We studied that when price falls, quantity demanded would increase. While we know this qualitative effect exists for most goods and services, managers and business analysts are often more interested in knowing the magnitude of the response to a price change. As managers or as business analysts, they are interested about the magnitude. That means by how much. So for that reason, we have to go for a quantitative concept. There are many situations in which one might want to measure how sensitive the quantity demanded is to changes in a product price. So here product price is actually independent variable and quantity demanded is a dependent variable. Economists and other business analysts are frequently concerned with the responsiveness of one variable to changes in some other variable. That is, changes in quantity demanded due to changes in income, due to changes in price, due to changes in prices of other goods like that. So it is useful to know, for example, what effect a given percentage change in price would have on sales. As you know, the managers and the managerial economists are interested in sales of a particular product. That is price multiplied by quantity demanded. So amount of quantity sold by them has a very big, has a very important influence on their decision making. So the most widely adopted measure of responsiveness, that is how to know that how much quantities we are going to sell in the market. For that reason, the most widely adopted measure of responsive is known as demand elasticity. Elasticity is a general concept that economists, business people, and government officials rely on for such measurements. For example, the finance minister might be interested in knowing whether decreasing tax rates would increase tax revenue or not. Similarly, it is also useful to measure the sensitivity of changes in demand due to changes in one of the determinants of demand. As we discussed earlier in the last class, the determinants of demand are income, advertising, price of other goods, etc. Now, elasticity is defined as the ratio of the percentage change in quantity demanded to the percentage change in some factor, such as price or income, which stimulates the change in quantity. The reason for using percentage change is that it obviates the need to know the units in which quantity and price are measured, because quantity and price are measured in different units. So for that reason, we take percentage. Why in percentage? Because a measure of elasticity based on units would lead to confusion and misleading comparisons across different products. For example, quantity could be in kilograms, grams, liters, or gallons, and price could be in dollars, rupees, euros, etc. So the use of percentage change makes the measure of elasticity independent of units of measurement and hence easy to understand. Elasticity is the percentage change in some dependent variable given a 1% change in an independent variable, ceteris paribus, that is other things remaining constant. Elasticity is the percentage change in some dependent variable due to 1% change in the independent variable. Suppose let us say y represents the dependent variable and x represents the independent variable. Then capital E stands for elasticity, let us suppose. So then capital E is equal to the ratio of percentage change in y and percentage change in x. There are two forms of elasticity, arc elasticity and point elasticity. Arc elasticity reflects the average responsiveness of the dependent variable to changes in the independent variable over some interval. The numeric value of arc elasticity can be found as follows. Changes in y divided by average of y divided again divided by, that means numerator is changes in y divided by average of y, and denominator is changes in x divided by average of x. So changes in y, suppose there are two values of variable y. At one time it is y1 and second it is y2, then the changes is y2 minus y1. Average is the summation of, you can take the simple average, arithmetic average, that is y1 plus y2 divided by 2, which is equal to 0.5 into y1 plus y2. So we can simply substitute that in that arc elasticity formula. So it will become y2 minus y1 by 0.5 into y1 plus y2 divided by x2 minus x1 divided by 0.5 x1 plus x2. Now look at 0.5, 0.5, they are same in numerator and denominator. That is why they will cancel out. So the subscripts above refer to the two data points, that is y1 refers to y at period at 1.1, y2 is y at 0.2. Similarly, x1 is at 0.1, x2 is at 0.2. So the subscripts here are actually it refers to data points or the extremes of the interval for which the elasticity is calculated, or original and final, you can say that way also. So point elasticities on the other hand indicate the responsiveness of the dependent variable to the independent variable at one particular point on the demand curve. So if the demand curve is going like this, at a particular point you can find out point elasticity of demand. But arc elasticity of demand is between 2 points A and B. Suppose you are taking 2 points on the demand curve, then arc elasticity can be calculated between those 2 points. That means it is changing, y is changing as well as x is changing at these 2 points. In case of point elasticity, we take the formula small e p is equal to, that is the first order derivative dy by dx with respect to x, derivative of y with respect to x multiplied by original value of x divided by original value of y, or we can say the first order derivative of y with respect to x multiplied by ratio of original value of the independent variable and the dependent variable. However, there are more independent variables. In that case, partial derivative must be used. You all know how to calculate the partial derivatives. Those were taught in block 1. So partial derivative means you are keeping other variables constant and taking the effect of one particular variable on the dependent variable. Suppose instead of x, y is a function of x. Now we can say that y is a function of three variables, w, x and z. So now here there is an influence of w on y, there is influence of x on y, there is influence of z on y. So here point elasticity of demand will be measured as, suppose EW, then that is the percentage change in y divided by percentage change in w, and which can be written as like this, that is del y by del w. The del symbol is actually there. Here it implies that y is a function of other variables, functions of variables other than w. And similarly, ex is equal to del y by del x into x by y and so on. Although economists use a great variety of elasticities, mainly three elasticities: price elasticity, income elasticity, and cross price elasticity, these three deserve particular attention because of their wide application in the business world. So now let us come. In this unit, we are going to study price elasticity of demand. What is the meaning of that? In that, we'll study our price elasticity, point price elasticity, and price elasticity and revenue, determinants of price elasticity, income elasticity of demand, cross price elasticity, then the effect of advertising on demand. Now, price elasticity of demand. You must all be familiar with the price elasticity of demand now. Let us discuss it again. Price elasticity of demand measures the degree of responsiveness of the quantity sold to changes in the product's price. Ceteris paribus. Since here we are discussing managerial economics, quantity sold in the market is actually influenced by the product's price. So that is why quantity sold, that is the dependent variable, and the product's price is the independent variable. So price elasticity of demand measures the degree of responsiveness of the quantity sold to the changes in the product's price. It is the percentage change in sales divided by a percentage change in price. We can also say like this. And the notation capital EP stands for arc price elasticity of demand, and small ep stands for point price elasticity of demand. One should note that since the demand curve is downward sloping, that is, price and quantity are inversely related, the price elasticity of demand will always be negative. Remember that. We are taking the mod value, and price elasticity of demand will always be negative. Now, if the absolute value of EP or AP, absolute value of capital EP or AP is greater than 1, a given percentage decrease or increase in price will result in an even greater percentage increase or decrease in sales. In such a case, the demand for the product is considered elastic. That means sales are relatively responsive to price changes. Therefore, the percentage change in quantity demanded will be greater than the percentage change in price. In simple term, we can say percentage change in quantity demanded divided by percentage change in price. If it is greater than 1, then it is elastic. Arc elastic, where we are talking about arc elasticity. Similarly, when the absolute value of the price elasticity of demand is less than 1, the percentage change in sales is less than a given percentage change in price. Demand is said to be inelastic with respect to price. And in case of unitary price elasticity, when a given percentage change in quantity sold is actually influenced by an equal percentage of changes in price, then that is also known as unitary price elasticity. The absolute value of the coefficient of price elasticity is equal to 1 in such cases. So if EP mod or mod EP, capital or small, price elasticity, point price elasticity or arc elasticity greater than 1, demand is elastic. If EP or EP is less than 1, demand is inelastic. And if it is equal to 1, demand is unitarily elastic. Now the formula, arc price elasticity, that is changes in Y divided by average Y divided by changes in, that is the ratio. The numerator is changes in Y divided by average Y. Denominator is changes in X divided by average X. So Y2 minus Y1 divided by 0.5. This you know earlier. Now that can be written as Y2 minus Y1 by X2 minus X1 multiplied by X2 plus X1 by Y2 plus Y1. You can write that way. Or you also can write down the difference of Y divided by the addition of Y, again divided by the difference of X divided by the addition of X. You can write this way also. Okay. Now, here is a demand schedule. Price is 90, 70, 50, 30, 10 like that. And quantity is actually 40, 120, 200, 280, 360 like that. Arc elasticities are calculated -4, -1.5, -0.767 like that. And point elasticity is calculated like this. Now let us look at the right hand side. We calculate the arc price elasticity, say between 30 and 10. So 10 is the final, or X2, and 30 is the original, that is X1. And similarly at 30, the quantity demanded is 280, and at 10, the quantity sold. Here we have to always mention quantity sold, because quantity demanded is by the consumers, and for the managers, they have to sell that quantity. So quantity sold is actually 280 and 360 respectively. Now new Y minus old Y divided by new X minus old X multiplied by new X plus old X divided by new Y plus old Y. That is the formula, and we are getting minus 0.25. Thus, demand is inelastic in this range because the value is less than 1. This value of EP means that a 1% change in price will result in a 0.25% of change in the quantity demanded over this region of the demand function. If we calculate the arc price elasticity between price of 50 and 70, we have it is minus 1.5, which is the mod value is greater than 1. So what do we find out? Find out here that at different points on the demand curve, the elasticities are changing. The arc elasticity was 0.25, forget about the minus sign, and now it is becoming 1.5 when the it is actually calculated price is between 50 and 70 and 50. Now, so demand is price elastic in the second case, but because the percentage change in sales is greater than the percentage change in price. And look at the figure, you find that elasticity of EP is actually changing. Now, point price elasticity, we can go for that point price elasticity. Let the demand function be P is equal to PQ is equal to 100 minus 0.25Q. We can write it as Q is equal to 400 minus 4P. Just take it to the left side. Q to the left side and P to the right hand side, you will get it. Now this is a demand function. Quantity demanded is a function of price. Now let us select at a point at which P is equal to 10 and Q is equal to 360. P is equal to 10 and Q is equal to 360. Look at the table there. Now, if you are calculating, we have to calculate dy by dx into original x divided by original y. That is the formula. So here dq by dp into p by q. Now dq by dp, if we are going through the formula, since dq by dp is equal to derivative of 400 minus 4p with respect to p, it is equal to minus 4. And now multiply that with p by q. P is equal to 10 and Q is equal to 360. So when price is equal to 10, our elasticity is equal to 0.11. That is less than 1. So point price elasticity is less than 1 at rupees when the price is rupees 10. Or we can say that the demand is inelastic at a price of rupees 10. Now consider a price of rupees 70. Now rupees 70, let us go back to this. 70, the quantity was actually 120. Quantity was 120. Now here dq by dp is already, we found it, dq by dp, that is minus 4, and multiply this by 70 by 120, that is equal to minus 2.33. It is greater than 1, so demand is price elastic. So the above example shows that the price elasticity of demand may vary along any demand function. Here also we find point price elasticity is 2.33 here, and it was 0.11 at different when price was 10, and it was 2.33 when price was 70. So that means if these example, the idea of giving these examples is actually to show that the price elasticity of demand may vary along the demand function. It is not constant, depending on the portion of the function for which the elasticity is calculated. Usually demand elasticities vary along the length of the demand function. So it follows that we usually cannot make such statements as the demand for product X is elastic because it is likely to be elastic for only one range of prices and inelastic for another. So basically what we are trying to say is that the demand for product X is elastic is not giving you the correct idea, because X may be, the demand for product X may be elastic at one particular price and it may be inelastic at another particular price. So usually the overall we can say that at high prices demand is elastic, while at lower prices demand tend to be inelastic. Intuitively, or when you think about it, just think lowering price from a very high level is likely to stimulate demand much more compared to lowering prices when the price is already low. The price is low and you are lowering the price, then the changes will be less or the stimulation will be less. Whereas if the price is very high and you are changing the price, reducing the price slightly, then the quantity demanded will be increasing or stimulated demand. Stimulated means if it is increasing, price is increasing, quantity demand is falling. price is decreasing, but demand it is increasing. So stimulating the demand. So as an illustration, consider the price of cellular phones and sets when these were the first introduced in the Indian market at prices ranging between 25,000 to 30,000 per handset. Demand was limited to only higher end of the market. That means only high income group people could buy that type of product, that is 25,000 to 30,000 rupees per handset. Now the prices suddenly fell because of the introduction of technology, or maybe the everyday change in technology, you can say. The demand was stimulated, and demand actually started, it resulted in increasing penetration in the middle and lower end segments. More production was there, and there was an elastic response. Now, price elasticity and revenue. There is a relationship between price elasticity and revenue, because if the manager or the firm or the producer wants to sell his product, he is always interested about his profit motive, about his profit. So he will always try to maximize his revenue. Revenue means price multiplied by quantity. So we have defined demand to be elastic when the absolute value of the price elasticity is greater than 1, that we have already told. To that statement is true. How it will be true? That will be true only when the percentage change in quantity demanded is greater than percentage change in price, because we said numerator is percentage change in quantity demanded or quantity sold in the market, you can say, and denominator is percentage change in price. So if numerator is greater than denominator, then we can say that it is elastic. So the price the demand has to be elastic or more than 1. Price elasticity must be greater than 1. That is possible when percentage change in quantity sold or quantity demanded is greater than percentage change in price. If this is true, then only we can expect to happen to a firm's receipts. The price, if this were true, what would you expect to happen to a firm's receipts if the price were lowered? Total revenue is equal to P into Q. Suppose that there is a 5% cut in price. Price is becoming less now. Now suppose price is less because of the law of demand. Quantity demanded will increase, so sales will increase. And suppose that is 50%. So if there is a 5% cut in price, that is stimulating a 50% increase in sales, then one would expect revenues to rise, because 50% increase in sale, price is falling. Even though it is falling, the percentage fall in price is much less than the percentage increase in quantity, because 5% is much less than 50%. So total revenue will obviously, it will increase. So the relatively small drop in price would be more than compensated by a large increase in sales. To see exactly this relationship between total revenue and price elasticity, let us take a demand function given by the equation which we took earlier. Q is equal to 400 minus 4p. From the above equation, now Q is equal to 400 minus 4p. We will convert it to price, that one side, and quantity on the other side. So price is equal to 100 minus Q by 4, and total revenue is equal to P into Q into 100 minus Q by 4 into Q is equal to 100 Q minus Q square by 4. Now marginal revenue. Marginal revenue, you know that it is the first order derivative of total revenue. Remember, anything marginal is always first order derivative. First order derivative of the total revenue is marginal revenue. First order derivative of the total cost is marginal cost, and so on. Now look at the figure. What is happening? That is, MR is equal to, after simplification, we find that it is 100 minus 0.5 Q. The change in expenditure when price changes is related to the elasticity of demand. If elasticity is less than unity or less than 1, that is inelastic, then the percentage change in price can exceed the percentage change in quantity, because the denominator will be higher than the numerator. Now this is the example here. Price, quantity, this is based on this formula, that is Q is equal to 400 minus 4p, or P is equal to 100 minus Q by 4. So price, Q, then TR, then MR, then EP. elasticity of demand can be calculated like this. And when Q is equal to 0, if this is the formula, Q is equal to 0, there is price is actually 100. Price is 100 even though the quantity of output is equal to 0. Now total revenue is actually, it is increasing. Look at the figure. Price is actually falling. Price is falling and quantity demanded is increasing, and total revenue is also increasing. Total revenue is all increasing up to the 280 units of output. It is increasing. Now marginal revenue is defined as the rate of change in total revenue or the additional revenue generated by selling one more unit. Now look at this graph. It illustrates the relationship between a farm's total revenue and the farm's demand curve over the range between 0 to 200 units of output. At that point, marginal revenue was 0. Look at here, at 50, when the price is 50, quantity is Q is equal to 200, marginal revenue is equal to 0. At that point, total revenue will be highest. Now, average revenue is the price. Elasticity will be greater than 1, beyond the midpoint towards the left of the midpoint, and elasticity is equal to 1 at the midpoint, and elasticity is less than 1 after the midpoint. That means it is more elastic towards the left. When price is high, it is elastic, demand is elastic. When price is low, demand is inelastic. So the total revenue and marginal revenue functions are shown here. And notice that the slope of the marginal revenue function is twice the slope of the demand function. In case of diminishing marginal revenue and average revenue, negatively sloped average revenue and marginal revenue, actually they got the slope of marginal revenue is twice, or you can say they got the distance, horizontal distance between y-axis and any point on average revenue will be divided into half. That is MR. MR is the locus of points. Those points are in between the distance from y-axis to any point on AR. Vertical, distance which is horizontal to x-axis. It must be parallel to, not horizontal, parallel to horizontal axis, that is x-axis. Because marginal revenue is the slope of total revenue, you can tell that increasing sales by lowering price will cause total revenue to rise over this interval. However, lowering the price when demand is inelastic, that is, we found that is here, that is after 200, what you find is that the total revenue is actually falling, because after 200 total revenue is falling. 10,000 it was, then after that it is falling, then there is an increase here, 14,400. There is a mistake there, there should be a correction. That is not 14,400. That will be 30 into 280. It will be 8400. That is a mistake. It will be 8400. That's a mistake. Sorry. That will be 8400. And you can correct that. That is 840. So it is actually total revenue is falling. So after, when Q is equal to 200, after that it is falling. Please correct that. That cannot be 14400. That is actually 8400. That is a mistake while typing. That's a typing error. Now from this example and from this graph, we can say that from the table, from the figure, we can reach some important conclusions about the relationship between elasticity, that is price elasticity, and total revenue. Now the price change will be the dominant one of the two changes, and the revenue will change in the same direction as the price change. If, however, elasticity exceeds unity, then the percentage change in quantity will exceed the percentage change in price. Yes, the percentage change in quantity will be the more important change, so that total expenditure will change in the opposite direction as the price changes. So elastic demand means decrease in price will lead to increase in total revenue. Increase in price will lead to decrease in total revenue. Price and total revenue move in opposite direction. And if the demand is inelastic, then decrease in price is leading to decrease in total revenue, and increase in price is leading to increase in total revenue. That is, price and total revenue move in the same direction. If a demand function has a unitary elasticity, then the same level of revenue will be generated regardless of price. For a linear demand function, as price falls, demand becomes less elastic or more inelastic. We have also seen that when demand is elastic, price cuts are associated with increases in total revenue. But if price continues to be lower in the range in which demand is inelastic, total revenue will fall. So this is the relationship between total revenue and price changes in price, because the manager or the farm or the producer is ultimately interested how much he is selling in the market and what should be his total revenue. So total revenue will be maximized at price at which demand is unitarily elastic. Demand is unitarily elastic. Look at here that the vertical distance from highest point of TR and the 200. Look at that, it is going through the point on average revenue curve or price, that is our demand curve. Average revenue is the demand curve that is going through E is equal to 1. Now, we can see from the figure that this point is also where MR is equal to 0. MR is equal to 0. Marginal curve is cutting the x-axis at that point, at 200. Okay. Now, this observation makes sense because marginal revenue is the slope of total revenue. We have already studied that any function may have the maximum or optimum value where its slope is 0. That is known as the critical value. First, we have to find out the first order derivative. Then we have to equate it to 0. Then we get the critical value. Then we find out whether the second order derivative is less than 0 or greater than 0. Since we are studying here revenue, it must be less than 0 for maximum. For greater than 0, it will be minimum. And here we are interested about optimum value in case of revenue, that is maximum. So we have to look for the MR, that is slope is equal to 0. MR is equal to 100 minus 0.5 Q. Now setting that equal to 0, we are getting Q is equal to 200. And now we have to go for the second order condition. Second order condition is nothing but the second order derivative of TR, or in other words, it is the d square TR by dq square, or it is the second order derivative is nothing but the first order derivative of MR, because MR is equal to dTR by dq. Now here where the result is minus 0.5, which is less than 0. That is negative. So because the second order derivative is negative, we know that total revenue is a maximum at Q is equal to 200. So the price at which 200 units will be sold is rupees 50. Here, 200 units will be sold is rupees 50, left hand side. So this is the revenue maximizing price. This is known as the revenue maximizing price. The relationship between elasticity and total revenue can also be shown using calculus. Total revenue, we know that is P into Q. Now taking the derivative of total revenue, that is nothing but the marginal revenue. I told you earlier, that is P into Q, derivative of PQ with respect to Q. So P into derivative of Q divided by derivative, P into derivative of Q with respect to Q plus Q into derivative of P with respect to Q. Because you know the product formula for the derivation of first order derivatives, product formula is like that. P and Q are products. So in that case, first function multiplied by derivative of the second function plus second function multiplied by derivative of the first function. Remember here P is a function of Q, and if first function is P multiplied by derivative of second function dq by dq will be 1 plus Q into dp by dq. Now this is equal to P into common, P take out the P common, and so that second half you can divide P there. So it becomes 1 plus Q by P into dP by dQ. Now what is the on the right hand side? That is nothing but your 1 by E. That will be elasticity. Just look at the right hand value and you can find out what is that value. The equation states that the additional revenue resulting from the sale of one more unit of a good or service is equal to the selling price of the last unit P, adjusted for the reduced revenue from all other units sold at a lower price. So Q into dP by dQ. So that is here a marginal revenue is equal to P common bracket within the bracket 1 plus Q by P into dP by dQ. Now that can be rewritten as 1 plus 1 by EP, because we have already known EP is equal to dQ by dP into P by Q. So that will be 1 by A. So this equation indicates that marginal revenue is a function of the elasticity of demand. For example, if the demand is unitary elastic, that is EP is equal to -1, then MR is equal to 0. MR is equal to 0. Because marginal revenue is 0, a price change would have no effect on total revenue. In contrast, if demand is elastic, say EP is equal to something -2 and mod value is 2, that is greater than 1. So marginal revenue will be greater than 0. This implies that a price reduction by stimulating a considerable increase in demand would increase total revenue. Total revenue will increase, but because the stimulation in the increase in demand will be so high that P into Q, that the total revenue will increase. This equation also implies that if demand is inelastic, say AP is equal to -0.5, marginal revenue is negative, indicating that a price reduction would decrease total revenue. So if a price reduction by stimulating a considerable increase in demand would increase total revenue when elasticity is demand is elastic, and price reduction would decrease the total revenue when the demand is inelastic. Two ways we can say. So some analysts question the usefulness of elasticity estimates. They argue that elasticities are redundant, such that the data necessary for their determination could be used to determine total revenues directly. Thus, managers could assess the effects of a change in price without the knowledge of price elasticity. However, elasticity estimates are still valuable to the extent that they provide a quick way of evaluating pricing policies. For example, if demand is known to be elastic, it is also known that a price increase will reduce total revenue. So the manager will be careful. Likewise, suppose the finance minister wants to increase the revenue through taxation by levying tax, then he knows that increasing duties on cigarette will most likely generate the result he desires, because the revenue is going to increase, because if he is actually increasing the duties on cigarette price is increasing, and what will happen is that is an inelastic good, so cigarette consumption will not be less and he can increase the revenue. Now this is the price elasticity of demand, a case study of a cigarette company. Now Swiss, sorry, so a Swiss American multinational cigarette and tobacco manufacturing company with products sold in over 180 countries. This I have taken from the book. In 2018, it cut its cigarette prices by 18%. Due to this decrease in price, their quantity sold increased by 12.5%. As there is an inverse relationship between price of the product and demand for the product. Okay, so when there is a cigarette prices were cut by 18%, due to this decrease, the quantity sold was increased by 12.5%. Later in 2019, it was found out that profits of the cigarette company fell by 25% due to this bad pricing strategy. Now the question arises, why profits fell despite increase in units sold? Here comes the concept of price elasticity of demand in picture. If we calculate price elasticity of demand in this case, it is as follows. That is, percentage change in quantity is 12.5 divided by percentage change in price is 18. That is equal to 0.69. It is less than 1, which means demand is inelastic. And demand is inelastic means, as we discussed earlier, the percentage change in quantity sold will be less than percentage change in price, and here the revenue will be less. Demand for cigarette is inelastic, and with decrease in price, total revenue of the fund decreases as increase in units sold cannot offset the lower price per unit sold. So here demand is inelastic, price is falling, quantity demanded is increasing, but the increase is not that good, that enough, so that total revenue is going to increase. Here what happened, actually price elasticity is actually your less than one. Okay, even though quantity demanded has increased, even though quantity demanded has increased. So the usefulness of elasticity in this particular case, we can say this particular cigarette company, the profits fell because they did not look at the elasticity side. It is so in this case, demand for cigarettes, okay, so total revenue decreases and total cost of production increases because more cigarettes were produced, which led to fall in profits. If cigarette company managers had paid attention to the economic concept of elasticity, they would have strategized better and profits would not have fallen. So their strategy became little bad because they did not take into account the concept of elasticity. Because if you are taking the concept of price elasticity, it is immediately telling you no, it is not going to be profitable. It's not going to be profitable because though quantity demanded has increased because of the price fall, it is not, and cigarette consumption is inelastic, but they are consuming more of cigarettes. People are consuming more of cigarettes, but actually when we are talking, looking at the response, degree of change in quantity demanded is not higher than degree of change in price. That is the result we are getting here. Now, what are the determinants of price elasticity? Now, determinants of price elasticity can be major three factors: availability of substitutes, proportion of income spent on goods and services, and length of time. Okay. Now, this is an example here. Estimates of price elasticity: goods or services, electricity, water, motion pictures, gasoline for and travel. Electricity in short run, electricity in long run, motion pictures, water, gasoline is in short run as well as in long run. Foreign travel is a long run thing. Motion picture is a long run thing. So estimated price elasticities are given like that. Now the long run demand for foreign travel, look at this by US resident. This is an example or table related to US residents is elastic. Mod value is 4.10 because it is more than 1. In contrast, the long run demand for water is 0.14, which is less than 1. So it is highly inelastic. Demand for electricity is inelastic in short run, but elastic in the long run. It is more than 1. The mod value is more than 1. So products for which there are good substitutes tend to have higher price elasticity of demand than products for which there are few adequate substitutes. Movies are a good example. Movies are a form of recreation, but there are many alternative recreational activities. When ticket prices at the movie theater increase, these substitute activities replace movies. Thus, the demand for motion pictures is relatively elastic. That is 3.69. So, it is relatively elastic. Other examples of products with close substitutes and therefore elastic demand would be demand for cars, demand for smartphones, demand for air travels, etc. At the other extreme, consider the short-run demand for electricity. Consider the short-run demand for electricity. It is inelastic in short run, but elastic in the long run. When your local supplier increases prices, consumers have few options. It is actually based on US economy. In our country, electricity was for a long time, it was under the control of the government. There, nowadays it has been privatized, but there the local supply, it was a private affair. So don't confuse with their example. Don't confuse their examples with ours, because our scenario is a little different. But still, looking at their economy, you can find out. So when the local supplier increases prices, consumers have few options. They do not have any option to switch over to another supplier. There are not many short-run alternatives to using electricity for cooling and lighting. Here, hence, the short-run demand for electricity is relatively inelastic. In the days of license Raj in India, when government was the monopoly provider, demand for telecom services like telephones was relatively inelastic since there was no other service provider in the market. Thus, a product with close substitutes tends to have elastic demand, One with no close substitutes tends to have inelastic demand. An important mission for most advertising is to make the consumer perceive that no close substitute exists for the product being advertised, thereby rendering the consumer's demand relatively inelastic. That means the advertisement should be in such a way that the consumer thinks that no other substitute is existing in the market. That is the idea behind the advertisement. So what will happen is that consumer will perceive or consumer will think that there are no close substitute for that particular product, and he will buy, and the demand will be inelastic. So proportion of income spent is the second determinant of elasticity. Demand, we are discussing about price elasticity. Demand tends to be inelastic for goods and services that account for only a small proportion of total expenditures. Consider the demand for salt. 1 kilo of salt will meet the need for the typical household for a month and cost only a few rupees. If the price of salt is increasing, even if it is doubling, this change would not have any significant impact on the family's purchasing power. As a result, price changes have little effect on the household demand for salt. In contrast, demand will tend to be more elastic for goods and services that require a substantial portion of total expenditures. Thus, demand for holiday travel and luxury cars, they take up a considerable portion of the family's budget and therefore tend to have higher elasticities. The relative necessity of a good also influences elasticity. For example, the demand for insulin is probably very inelastic. Now, time period is another determinant. Demand is usually more elastic in the long run than in the short run, as we discussed earlier. The explanation is that given more time, the consumer has more opportunities to adjust to changes in prices. Table in the earlier slide indicates that table I gave you, that is regarding electricity, and we found that the long run elasticity for electricity is more than 10 times the short run value. The short run elasticities reflect periods of time that are not long enough for the consumer to adjust completely to changes in price. The long run values refers to situations where consumers have had more time to adjust. Now, price elasticity and decision making. What should be the connection? Information about price elasticities can be extremely useful to managers as they contemplate pricing decisions. What should be the price? That decision actually should be based on price elasticity. If demand is inelastic at the current price, a price decrease will result in a decrease in total revenue. Alternatively, reducing the price of a product with elastic demand would cause revenue to increase. The effect on total revenue would be the reverse for a price increase. If the demand is unitary elastic, price changes will not change total revenue. However, a price reduction is not always the correct strategy when demand is elastic. Remember that. Price reduction is not always the correct strategy. The decision must also take into account the impact on the farm's cost and profits. And the pricing strategy should include farm's cost and farm's profit. So decision making should not be only on the changes in price, it should be on the cost as well as on the profit. The example here, like how price elasticity may be useful. Let us consider the demand for cigarettes. Left hand side is the age group, right hand side is the price elasticity. We find here is that from the perspective of cigarette sellers, the results here suggest that if all sellers increased prices proportionately, the total expenditure on cigarettes by adult smokers would increase. Adult smokers are 20 to 25, 26 to 35. So recall that when demand is inelastic, price and total revenue move in the same direction. Okay, so this may be in part related to the fraction of income that goes towards the purchase of cigarettes. These elasticities indicate that young smokers are much more responsive to price than our older smokers. So individual brands also would be more price elastic than for the entire product class, because each brand has other brands that represent potential substitutes. Now, income elasticity of demand. Again, here we'll discuss about arc income elasticity and point income elasticity. Arc income elasticity is the calculation is just like the price elasticity, but only difference here is that instead of P price, we are inserting I. I stands for income. That is, the formula will remain same for arc income elasticity and point income elasticity. Only thing that I will be substituted for P. Now, given information on sales and income, the calculation of income elasticity is strictly analogous to the calculation of the price elasticity. Now, income elasticity of demand, if it is greater than 1, the product is said to be income elastic. If it is less than 1, then it is said to be income inelastic. For normal goods, the income elasticity is greater than 0. Because with rising incomes, consumers will purchase a greater quantity of such goods, other things remaining constant. If the income elasticity for a commodity is negative, the goods may be inferior good. That is, people will choose to purchase less of the product when their income increases. Potatoes may represent examples of inferior goods. The reason is that some households consume certain goods only because of the reason is that some households consume certain goods that is only because of lack of purchasing power. And as income increases, it is possible the household will shift away from the purchase of these inferior goods and it will consume the normal goods. The relationships are like this. Normal goods are indicated by point elasticity of income or arc elasticity of income if it is greater than 0. Inferior goods if it is less than 0, inferior goods. And if it is greater than 1, good income elastic, less than 1, or income inelastic, then unitarily income elastic. Usefulness of income elasticity. Suppose a farm has obtained a fairly reliable estimate of the projected percentage increase in income for its market area for the next year. Let us say 4.5%. That is 4.5% is the reliable estimate of the projected percentage increase in income of the consumer where he is selling the product in the market. So managers know that sales are currently running at an annual rate of 2 lakh units. And the marketing analysis group has estimated the arc income elasticity of demand for the product at 1.2. Okay, so arc elasticity of income elasticity for the product is 1.2 and annual rate of selling, currently the sale is 2 lakh units and income is going to increase like some 7th pay commission or something, the income is going to increase by say 4.5%. If other factors are expected to remain relatively constant, we can use this information as one input into projecting sales for the next year. Percentage change in Q divided by percentage change in income. Percentage change in Q is equal to nothing but E1 into percentage change in income. E1 arc elasticity, sorry, not E1, sorry, EI. I couldn't see it properly. EI is 1.2 from the earlier slide. We know that was the question given, and 4.5 is equal to 5.4. So next year's sale would be projected to be 5.4% above the current level. That means if this year we are selling 1, the next year we are going to selling 1 plus 1 plus 1.1 plus 5%, that is 5.4%, 1.054 times. So this year the sale is 2 lakhs units multiplied by 1.054, then that is giving us 2,10,800 units. So knowledge of income elasticity is also useful at different stages of a business cycle. For example, during period of expansion, farms selling luxury products such as exotic vacation or big cars find that demand for their products will increase at a rate that is faster than the rate of growth of incomes. If the demand for the product increase is faster than the rate of growth of the income, then the farms can sell luxury product and can expand. However, during the recession period, demand may decrease rapidly. Conversely, sellers of necessities such as basic foods will not profit much during the periods of economic prosperity, but will also find that their products are recession proof. Their products are not going to be affected either in recession or in expansionary phase, that is the inflation. So in this way, we can say that income elasticity of demand is important. Now, the next one is cross price elasticity. Here, cross price elasticity means we are discussing, that is, suppose price of Y is changing and there is a substitute good for Y. Another good is available, which is substitute for Y. Then we can say, what is the impact of change in price of that substitute on the quantity demanded of Y. We can say that way. So cross price elasticity of demand provides a means to quantify that type of influence. That is, the sales volume of one product may be influenced by the price of either substitute or complementary products. It is defined as the ratio of the percentage change in sales of one product to the percentage change in price of another product. Suppose there are two products, products 1 and 2. Then one is the relevant arc is C and point is C. Cross price elasticities are determined like this. There are two products, price, suppose quantity, products are A and B. So quantity at period 2 at final quantity of B minus original quantity of B divided by final price of A. A and B are related, they are complementary or they are substitute, you can say. So basically, percentage change in quantity demanded of B as a percentage change in price of A. That is the basic idea behind cross price elasticity. That is written here, and B1, B2 stands for quantity of B in period 1 and quantity of B at period 2, and A1, A2 stands for quantity of A at period 1 and quantity of A at period 2, and PA2 stands for price of A at period 2, and similarly QB2 stands for quantity of B at period 2. Similarly, QB1 stands for quantity of B at period 1, because we are calculating arc elasticity. In case of point elasticity, there is no problem. dQA by dPB, quantity of A divided by the change in quantity of A, or percentage change in quantity of A divided by percentage change in price of B. That also you can say, or the percentage change in quantity of B divided by percentage change in price of A. You can calculate that way also. You can write that way. A negative coefficient of cross price elasticity implies that a decrease in the price of product A results in an increase in sales of product B, or vice versa. We can conclude that the products are complementary to one another, like cassette tape players and cassette tapes. When the coefficient of cross price elasticity for two products is negative, the products are classified as complements. A similar line of reasoning leads to the conclusion that if the cross price elasticity is positive, the products are substitute. For example, an increase in price of sugar would cause less sugar to be purchased, and less sugar means there will be increase in sugar substitutes, sale of sugar substitutes. When we calculate the cross price elasticity for this case, both the numerator and the denominator would have the same sign, and the coefficient would be positive. Here, this is case of substitutes. So if two goods are unrelated, a change in the price of one will not affect the sales of the other. So the numerator of the cross price elasticity ratio would be 0, and thus the coefficient of cross price elasticity would be 0. In this case, two commodities would be defined as independent. For example, consider the expected effect that a 10% increase in the price of eggs would have on the quantity of electronic calculator sales. That is totally independent. The cross price elasticity will be 0, because change in price of eggs is not going to affect the quantity demanded of electronic calculator, or quantity of sales, change in sales of electronic calculator. So from this we can say cross price elasticity is greater than 1 for substitutes, less than 1 for complementary, and equal to 0 for independent goods. Cross price elasticity may not always be symmetrical. So, like suppose there are two dailies A and B competing in the daily market, most analysts will agree that the two products are substitutes, and the cross price elasticity is positive. However, there is no reason to believe that, because for suppose the change in demand for the A following a 1% change in the price of B will be equal to the change in demand for B following a 1% change in the price of the A. That is symmetric, but it is not that way. Many large there is no reason to believe that that will happen. Okay, so many large corporations produce several related products. Automobile companies produces many varieties of automobiles. Detergent company produces many brands of soaps. Automobile company, suppose it reduces the price of its A model, then sale of its related S model may decline. When a company sells related products, knowledge of cross elasticities can aid decision makers in assessing such impacts. So, cross price elasticity is useful for companies which are producing related products. Now, the effect of advertising. The effect of advertising influences our attitudes towards the product or service being promoted. So basically, when Pepsi Cola Corporation decides to sponsor a television show or cricket match, it hopes that its goods are going to be sold. More of Pepsi are going to be sold. These are known as product promotions. In addition to shifting the demand function to the right, advertising may have the effect of making it somewhat more steep. Now, the reason for this is that advertisements can create stronger consumer brand for preferences, thus making consumers less sensitive to price changes for that product. One effect of advertisement can be to make the demand for a firm's product more price inelastic. To the extent that this is true, management has an increased ability to raise price without losing as many sales as would have been lost otherwise. So we have seen that raising the product's price will increase total revenue for the farm if demand is inelastic. So the summary is that concept of elasticity is very important from the manager's point of view or from the seller's point of view. Price elasticity is there, then income elasticity is there, then cross price elasticities are there, then all these are helpful in decision making of the farms or the sellers. And there is advertisement part is also there, because farms can make the consumers demand inelastic by spending more on advertisement, or they try to make the consumer perceive that there is no close substitute for their product. Like that we can study. These are the effects and these are the concepts. Thank you.